All right, we're looking for the pineapple example, the null and alternative hypothesis. So MM, give me the null that you think. Something to do with the mean.
Was it 31?
All right, so on this one, they mentioned that the field Harvard is 31 before the irrigation system. So, which direction do you think we're going to go with the alternative hypothesis? If you put in an irrigation system, does it indicate which way
No.
we should go?
It just says will affect the mean weight.
Okay, so it says affect the mean, so we don't care if it's higher or lower. So that's why we're doing a two-sided test to see how it works. So we're going to say does not equal 31. All right, so if I was doing it, I would hope that the irrigation system would increase the mean size, but I guess they're thinking, what if they shrink when we put in the irrigation? That's kind of unlikely, but we'll go with their leadings. We're really just studying a two-sided test.
Is X bar 31.935?
Really? Okay.
31.935, yeah, where'd you get that? From the mini tab, right? Where it says mean. Okay, so start building your
We have an
team.
alpha level when we use.
If they don't say, we say 0.05. I don't see one.
Okay.
Don't we use X because we know the standard deviation? I mean, not Z, not T.
Where do they give us the
I
standard
mean, I
deviation?
think
That's
that's
for the sample.
Yeah, the standard deviation is for the
Okay.
samples.
Yeah.
So we can't. Is camera still filming?
Mm-hmm.
Hi, I'm Kane. Where is she at? South Carolina?
She's driving to South Carolina right now.
Is she actually driving?
No. Oh, her parents said they might make her drive. I hope they didn't make you
Are
drive.
they going to Roanoke?
You're going?
No, are they going to
Oh,
Roanoke?
I have no idea.
If you're going to Roanoke,
No,
Yeah,
that's
they'll go for
Virginia.
Roanoke.
really?
Yeah, they're going to South
I
Carolina.
know, but they'll
No,
go
but it's in
down
Roanoke, South
81. They'll
Carolina.
probably go through Roanoke. Why?
Roanoke's
No.
Virginia.
Why, you don't know?
I don't know. That was like the one history lesson I learned from like 5th grade. It was like a bunch of people there, and then they disappeared. Probably got killed off the scout.
Okay.
Did you set up your T statistic? Mean minus the mu naught divided by the standard deviation from the mini tab divided by square root of 50. So anyone got that?
I got 2.76.
2.76, that's mighty high. So I smell a rejection.
I have to do it in the calculator. I like to do it both ways.
Alright. So we're looking up now the p-value from this T statistic. So on chart B, I got...
Oh, but you only have to multiply by 2?
Yes, we do. So I got this range
Yeah.
between 0.0025 and
Did you get in the
the
calculator?
DF I had to
2.76.
use on that chart was way down at 40.
I
So
didn't do that.
we're going to be way conservative on this
Miss
because,
Mel.
yeah,
What do you do for the calculator because it's two-sided, so what is the minimum and max?
you're going to have to take the p-value that they give you and double it.
So you
say
can't do it on the
0.004.
calculator?
Right. Well, you just do it regular, and then you have to bring the brain power to say double it.
But
As
how
far
do
as
you...
I know.
The same way as before, second bars.
I know, but what's the minimum?
Minimum is 2.76.
What's the maximum?
Just like 100.
I mean, it's funny.
But
that
if
they-
it's two-sided is
they
what I'm
say that
saying, then that wouldn't be the minimum.
the
Because it
mean
could go either way.
is 31.
Well,
that's their
what she's
claim.
saying after.
And the
after
mean
you
for
get
the
that, you
sample
multiply
is
that
just
number by
31.935, yet that's like 2.76 deviations away. That's
I know.
crazy.
Yeah, it's a pretty big.
It's weird.
All right,
What did you end up
so
getting?
what did your calculator give you?
Point-
MD?
0.0043. Hold on, let me multiply by
No, I
2.
mean the probability.
Oh.
So you're going to go to
Yeah, that's what I got.
Yeah, and then
Point-
what'd you get?
0.0086.
0.008, and so then you're going to have to double that.
Well, that's
No, that
after
is doubled.
That's already doubled.
Yeah, I got
Alright, is
point-
that in this interval?
Yeah.
Yeah.
It is.
I'm like, I don't
Yeah,
know.
your decimals, yeah.
Um,
Alright, so the point being, if you do it on the chart, you take the range, or I guess the range of it, the interval range, and double both sides, and you get the final p-value. If you do it on the calculator, they'll give you one value, you have to double it. Calculator doesn't do that.
So it's actually greater than point. Actually, it's not.
so could you do it? Could the 2.76 be either the lowest or the greatest? It doesn't
Yeah.
matter.
Yeah,
So we're gonna
Oh, right.
reject it,
We
right?
got .004 on the calculator.
okay.
Wait, we used degrees of freedom is 40?
Well, just because
It's around
it was
that.
50, and degrees of, that's for the chart. So degrees of freedom is 49, but on our chart, we had to go all the way down to 40, because it didn't have 49. But on the calculator, you can use 49, and be a better, it'll be a better result.
What did y'all get?
What for?
Calculator.
Calculator,
Then you have to double it.
we have the double .008
This is
because,
double sided. Hey,
Oh,
double
right.
it because it's double sided.
Oh my gosh, guys, I'm not supposed to remember this stuff again.
wait a minute, when I double, oh, you said that was already doubled, never mind. You said that was doubled.
Yeah.
Yeah.
Okay.
So originally you
So
get
double is
.008.
.008, and that is in the same interval that the book chart B gave us.
It's confusing.
So, what's the conclusion?
We reject.
Alright, because that is way rarer than .05, we're gonna question that, which we thought we were going to. So reject the null hypothesis in favor of the alternative. But on your papers, you're saying that, and I want you to take it into the problem itself. So you would say what? Yes, in this particular case, we will
So-
reject H sub O, but what conclusion?
Wait, does that mean that originally when you get like the original interval from this, which
Yeah.
is like .0025
Yeah,
to .005,
yeah,
is okay.
and we had to double each of those.
So reject the old pineapple production in favor of the new irrigation system.
Right, well, all we could say, I don't really know if we can say but we can say, we know, this test has shown us that the mean weight is no longer 31. We don't know if it's higher or lower, but we can say it is not 31.
So how do you say that though in terms of reject?
And
Reject.
so you say we'll reject the hypothesis that the mean didn't change. The irrigation, we will reject the null hypothesis that states that the mean weight did not change with irrigation in favor of the alternative hypothesis which says it did change from the mean weight previously noted. Alright, can we say, oops, that's a phone call, isn't it? Boston? Who's calling me from Boston? I got it now. Hello? But, wow. There's a bunch of people talking in the background.
Disappointing.
Alright.
Listen in, put on speaker.
Can we say that irrigation caustic change?
No.
Good girl, why? How do you spell irrigation?
Because
Is it 2
probably.
R's, irrigation?
Yeah.
Can we say that irrigation caused,
Because
That
this
change.
whole thing isn't about causation.
Right.
It's just about probability.
Causation. What is it?
right,
Uh,
Association.
associ-
Not equal causation.
right, we would